Hello class, welcome to day 5. We're going to do more related rates, more word problems, more applications of how we use calculus to figure out problems. So I'm going to put down my key, and we have this example where we have this 13-foot ladder again, leaning up against the house. So let's see, what do I know? Well, I know that z is equal to 13 and z prime is equal to 0 because the length of the ladder does not change. And the base starts sliding away. By the time the base is 12 feet away from the house, the base is moving at 5 feet per second. That means x is equal to 12 feet, and x prime is equal to 5 feet per second. So if I want to figure out the missing side, let's see, 12 squared plus y squared is equal to 13 squared, and I get y equals 5. So y equals 5, and y prime equals my unknown. I do not know that. Of course, my Pythagorean theorem, x times x prime plus y times y prime is equal to z times z prime. I'm going to fill in with what I know. 12 times 5 plus 5 times y prime is equal to 13 times 0. And obviously I get 60 plus 5y prime is equal to 0. 5y prime is equal to negative 60. And my dy over dt is equal to y prime is equal to negative 12 feet per second. So now I'm going to figure out how the area is changing. Move this up a little bit. So area is 1/2 base times height, or for this problem, area is 1/2 x times y, which means I'm going to have a product rule. I have 1/2 x, and that derivative is 1/2 x prime, and I have y, and that derivative is y prime. So when I take the d dt of all this, I get a prime is equal to 1/2 y x prime plus 1/2 x y prime. I just figured out y prime earlier. And a prime is equal to 1/2 y is 5, x prime is also 5, plus 1/2 x is 12, my y prime is negative 12, and when I'm done, I get dA over dt is equal to a prime is equal to negative 59.5 area square feet per second. So I redrew my picture down below at part C because I can't see it up at the top because I scrolled my page down. I had to figure out how is the angle changing, this theta in red, and I use sine, opposite of hypotenuse, which is side y over side z, and I like using side z because z is constant. It's never going to change. So now I got to take this derivative. Derivative of sine is cosine theta, but a variable, theta prime, is equal to, well, this is 1 over 13 times y, so it's 1 over 13 times y prime. That is my derivative. Well, I have to figure out cosine for this picture. So cosine for this picture, according at the moment, cosine is adjacent over hypotenuse, which is x over z. So cosine right now in the moment is 12 over 13. So this becomes 12 over 13 times theta prime is equal to 1 over 13 times my y prime is negative 12. Well, to get rid of that fraction to solve for y prime, I'm just going to multiply this whole thing by 13 over 12. I get d theta over dt, which is my theta prime, is going to be negative 1 radian per second. That's how fast that angle is changing. So the next problem of an airplane flying over a radar antenna, y is 7, y prime is 0 because that distance will never change. Z is given at 10. Z prime is also given at 300 miles per hour. I use the Pythagorean theorem to figure out x, and I get the square root of 51. And I'm trying to figure out x prime. Again, just going to fill in with what I know. I have the square root of 51 times x prime is equal to 3,000. I'm going to divide out by the square root of 51. And how fast is the airplane going? About 420 miles per hour. Okay, for the next problem, I have sand falling from a conveyor belt at a rate of 10 cubic meters per minute. And here's my little diagram, and it falls into a pile that makes a cone. And the height of the pile is always 3/8 its diameter, and that's the little equation I have here. So my height is equal to 3/4 times 2 times the radius, or my height is equal to, oh, I made a mistake. Go back. Gotta read my words better. This is 3/8. My bad. The height is 3/8 the diameter, or 3/4 of the radius. And what I can do is saying that r is equal to 4/3 the h. And that is going to be key. I'm going to be using this as a substitution. Because right now I have bottom of a cone, which is given to you as 1/3 pi r squared h. I don't want to deal with two variables. I'm trying to find how fast the height is changing, or I'm trying to find h prime. Sorry it took so long. So I can get rid of this guy and say v equals 1/3 pi 4/3 h squared times h, or v equals 1/3 pi times 16 over 9 h squared times h, or volume is equal to 16 over 27 pi h cubed. This is the equation I'm using based on getting rid of the r. So now I could take its derivative. I'm going to take the d dt of all this, and I get v prime is equal to 16 over 27 times pi 3r squared times h squared times h prime, or v prime is equal to 16 over 9 pi h squared times h prime. And let's fill in with what I know. Well, what do I know? I know my v is 10. V prime is 10. I have 16 pi over 9 times 4 squared times h prime. And this is a little bit jumbled up together, but change colors, make it orange. I get 10 equals 256 pi over 9 times h prime. And how do I get rid of this fraction in front? I multiply by its reciprocal. So I'm going to multiply by 9 over 256 pi, and I get h prime equals 90 over 256 pi, or when I put this in my calculator, I get 0.112 meters per minute, but I want my result in centimeters per minute. So when I'm done, dH over dt is equal to h prime is equal to 11.2 centimeters per minute. Sorry, I kind of ran out of room here, but I have the notes online if you want to follow those. As you can see, I have to get rid of r or h when I do a co-problem. I do not want to deal with two variables. And I'm going to go to the second part below. So in part A, we figured out how is the height of this pile changing, and it was 11.2 centimeters per minute. Now we want to figure out how the radius is changing. Well, I have this equation, r equals 4/3 h, and all I have to do now is take this derivative. R prime equals 4/3 times h prime. Well, I know what h prime is. R prime is 4/3 times 11.2. So I get dr over dt is equal to r prime is equal to 14.9 centimeters per minute. So for this problem at the moment, when the height was 4, the height was changing at 11.2 centimeters per minute, and the radius is changing at 14.9 centimeters per minute. Okay, now we have this triangular prism trough, and we're trying to figure out how the height is changing for the given problem. Well, the dimensions of the trough are the top is 6 feet, the height is also 6 feet, and the width of the trough is 16 feet. Well, the volume is just area of the triangle times the width, or 1/2 base times height times width. But we have a nice little thing here. We have the width is equal to 16, and it's constant. It's never going to change. So I get volume equals 1/2 times base times height times 16, or I get 8 times base times height. That is the volume of this trough. But we also have the idea that the base and the height are always the same, no matter what level you're at. If you're at a height of 2 feet, the height is 2 feet, and so on and so forth. Okay, so I can get rid of it and rewrite it as volume is equal to 8 times h squared, and now I can take its derivative. You get v prime is equal to 16h times h prime. And what do I know for this problem? Well, I know my v prime is equal to water is being pumped in at a rate of 4 cubic feet per minute, and when the height is 4. So I could put in 4 is equal to 16 times 4 times h prime, which is 64 h prime. And when I'm done, I get my dh over dt is equal to h prime, which is equal to 1/16 of a foot per minute. So with this big giant trough, where you're pouring in 4 cubic feet per minute of water, the height is increasing by 1/16 of a foot per minute. So for my next problem, I have the spherical balloon. Volume of a sphere is 4/3 pi r cubed. I can take its derivative. I get v prime is equal to 4 pi r squared times r prime. And what do I know? Well, I know my v prime is equal to 100 pi. My radius is equal to 5. My radius is equal to 5. So I'm trying to solve for r prime. How fast is the radius increasing? So I can plug in all those numbers. 100 pi equals 4 pi times 5 squared times r prime. 100 pi equals 100 pi times r prime. And I get dr over dt is equal to r prime is equal to 1 centimeters per minute. So in the moment, the radius is increasing at 1 centimeters per minute. So how do I do surface area? Well, surface area is equal to 4 pi r squared. That is the formula for surface area of a sphere. I can take its derivative. I get surface area prime is equal to 8 pi r times r prime. I know my r, I know my r prime, and I could do as 8 prime is equal to 8 times pi. The radius is 5. My r prime is 1, which I just figured out in part A. So my dSA over dt is SA prime is equal to 40 pi. This is area, so centimeters squared per minute. My volume is changing by 100 pi cubic centimeters per minute. My radius is changing by 1 centimeters per minute. And my surface area is changing by 40 pi centimeters squared per minute. Okay, this last problem is a kind of like a dual problem. It's the idea of you have a coffee draining from the filter that's shaped like a cone into the coffee pot that's shaped like a cylinder. So the volume for a cylinder is pi r squared h. But here's the thing. For the cone, for the cylinder, my radius is equal to 3, and that's going to be constant the whole time. For this cylinder, r equals 3, and it's constant. It never changes. So when I rewrite this, I have v equals 9 pi h. Well, that's a nice, easy equation. I like that one a lot. Take its derivative. V prime is equal to 9 pi times h prime. Well, let's see what's going on here. Right now it says it is draining at 18 pi inches cubed per minute, and that's my V prime. But the one thing I do know is that the V prime in the filter is equal to the V prime in the pot. So whatever dripping out of the filter is dripping into the pot. The rate of change for the volume is the same for both. Well, that's going to be 18 pi equal to 9 pi times h prime. So my dh dt is equal to 2, and this is inches per minute. So in the coffee pot at the moment, the height is changing by 2 inches per minute. This 5 inches in the cone didn't really matter. I didn't need it for this part of the question. Okay, in the bottom here, I redrew the shape of the cone or the triangle. When my height is 6 of the filter, my radius is 3, so my height is twice the radius, or better yet, my radius is half the height. I'm going to use this in the V equation again. Here's my volume equation. I'm going to get rid of this R. V equals 1/3 pi, 1/2 h squared times h. I think we've done this many times in the last couple classes. 1/12 pi h cubed. That is my volume of the filter. I also know my height is 5, and my V prime is equal to 18 pi. I'm going to move this up a little bit. Get some space. I'm going to take its derivative. Which again, we've done enough. V prime is equal to 1/4 pi h squared times h prime. I know my h prime is 18 pi is equal to 1/4 pi times 5 squared times h prime. H prime is the one thing I do not know. I get this, I get 18 pi is equal to 25 over 4 pi times h prime. And I'm going to get rid of that fraction. I'm going to multiply by 4 over 25 pi. And I get my dh over dt, which is h prime, is equal to, well, the pi's cancel out. I get 72 over 25. It is measured in inches per minute, or you could say h prime equals 2.88 inches per minute. So for this problem, we had the height of the coffee pot changing at 2 inches per minute, and the height of the cone was changing at 2.88 inches per minute.